Alright, so now that you know how to factor, we're going to look at solving again. So there's not much difference to solving again. I'm not going to fill out too much this top, but just remember that you set the polynomial equal to 0 first. Factor out any common factors, look for your special patterns. You know how to factor. To finish it, you're going to set each part equal to 0 and solve for the variable. You will have some real solutions and some imaginary solutions. So looking at these examples, step 1. Okay, and it's not going to tell you, hey, you should factor this one by grouping or by taking out the greatest common factor first. It's not going to say that. You have to know your methods to factoring and where you need to start. So in this case, step 1 is always factor out the greatest common factor. In this case, that's just a w. If I take the w out, that leaves me w minus 3. Okay, now I am solving this. So to find my solutions, I set my factors equal to 0. I set w equal to 0. I set w minus 3 equal to 0. This one's easy. That's already solved. I add the 3 to the other side. W equals 3 is my other solution. And I found my two solutions to this equation. Okay. Now one thing to kind of know is there are these rules of algebra, and I'm not too worried about them. We're going to look at them more in the next chapter after Christmas. But if you had a w squared as your biggest term, we're going to talk about more about that later too, but that means you should have two solutions. So w squared should have two solutions, and x cubed should have 3 solutions. So we'll check that out as we get there. This next one, already set equal to 0. It's just a normal factoring. I can draw my two parentheses. Minus plus means that these two both need to be subtraction. We're going to start with an x, what multiplies to be 6 and adds to be 5. That's 3 and 2. Again, if those are your two factors, you set them both equal to 0 to find your solutions. That means x equals 3 and x equals 2. Again, I had an x squared to start with, so I should have two solutions. Looking at the next question, remember step 1 is always to set it equal to 0. Right now it's not set equal to 0. So I need to subtract these things to the other side. When I do that, again, I recommend moving it over to the side that's going to keep the biggest x positive. Okay, so even though it would have been just as easy to subtract these to the other side, and you could have, I just think it's much easier to factor when you're keeping those positive. Okay, looking at this, if I have 4 terms, it's a pretty good indicator that I'm going to have to factor by grouping. Looking at the first 2, I can actually take an x squared out of that. That leaves me with an x plus 1. Looking at the back 2, I could take a negative 9 out of that. That also leaves me with an x plus 1. To factor this, again, those are the same. That gives x plus 1. These go together to become the other one, x squared minus 9. But this can actually factor even further. That factors, that's a difference of squares, x plus 3, x minus 3, and x plus 1. Again, I'm finding my solutions, not just factoring. So I set all 3 factors equal to 0 to find my 3 solutions. X equals negative 1, x equals negative 3, and x equals positive 3. Again, this one led off with an x cubed, and I had 3 solutions. The next one is already set equal to 0. Again, it's a factor by grouping because I have 4 terms. So looking at these first 2, I can factor an m squared out of that. That leaves me with an m minus 2. Looking at these back 2, I can factor a negative 4 out of that. That leaves me with an m minus 2. Again, those should match, and they do. M minus 2 is one of my factors. M squared minus 4 is the other. Okay, this one factors further. M plus 2, M minus 2. Okay, this is now completely factored. I set it equal to 0 and find my solutions. Now in this case, notice M equals 2, M equals negative 2, and M equals 2 again. Technically, you don't have to write it twice. 2 is what we call a double root, and in our next lesson, we'll be looking a lot more about what happens graphically at a double root. But I still, if you notice, have 3 solutions, even though one of them is doubled. Okay. I just have a couple more problems here. Question number 5. Again, step 1, set it equal to 0. It means I need to move this 384 to this side. Okay. When I factor out my greatest common factor, in this case it looks like that might be 6. Take out the 6, that's v cubed minus 64. Okay. Now I have a perfect cube. 6b minus 4, again, square it, multiply them together and change the sign, and square it. Okay. When you're looking at your solutions for this one, okay, this first one's super easy to find. I set v minus 4 equal to 0. That gives me v equals 4. For the next one, like I said, this isn't going to factor further, and it's not going to. If you're going to find your solution here, you are going to have to do the quadratic formula. A equals 1, b equals 4, c equals 16. Okay, so I'm going to just negative b plus or minus the square root, b squared minus 4ac, all divided by 2a. So in this case, that's a negative 4 plus or minus the square root, all divided by 2, and I'm going to do just a little bit of calculations over here. B squared, that is going to be 16 minus 4 times 16 times 1. This is a negative 48. Gross. Okay, so what is the square root of negative 48 going to be? Well, first of all, I can factor tree this out. That's 4 and 12. That's 2 and 2, that's 2 and 6, that's 2 and 3, so I got a pair of 2s, 2 pairs of 2s. That means I could take a 4 on the outside. 3 is going to stay inside. I can also, since this is negative, bring an I to the outside. So this becomes negative 4 plus or minus 4I square root of 3, all divided by 2. I can simplify this just a tiny bit more by dividing this, and this all by 2. So x actually equals negative 2 plus or minus 2i square root of 3. Okay. Now notice this one had an x cubed or a v cubed in this case, so I should have had 3 solutions, and I do. Here's 1. This is actually 2 because you have the plus 1 and you have the minus 1. So that's 2 different solutions there. Okay. I don't think there's just tons of these where you're going to have to do the quadratic formula, but that's okay. It's not that bad. Looking at the next question, again, step 1, get it equal to 0. Subtract the 36 to this side. P cubed plus 4p squared minus 9p minus 36 equal to 0. Again, I can group this. 4 terms, that's a good indicator. I'm probably going to be able to group it. Taking out a p squared, that leaves me a p plus 4. Looking at the back, I can take out a negative 9, p plus 4 also. That gives me 2 factors of p plus 4 and p squared minus 9. Again, your p squared minus 9 happens to factor further. It's kind of nice. It's better than doing the quadratic formula anyway. And again, I'm going to have my 3 solutions. In this case, p equals negative 4, p equals negative 3, p equals 3. All right, one more. Again, step 1, set it equal to 0, which means I need to move this over here. And my recommendation is to put these in order. So notice this is an r to the 7th. Really, an r to the 6th should go next. So that's what I'm going to do. 6r to the 7 minus 9r to the 6th plus 6r to the 5th minus 9r to the 4th. Okay? If you remember correctly, step 1 is actually to take out your greatest common factor. In this case, that is going to be a 3r to the 4th. I can divide at least 3r to the 4ths out of all of these. That leaves me with a 2r to the 3rd minus 3r squared plus 2r minus 3. Okay. Again, factor by grouping. Looking at my greatest common factor here, that looks like it's just an r squared, 2r minus 3. Greatest common factor here, there's actually not one, so remember that's an understood 1, 2r minus 3. Okay. So my factors here, 2r minus 3, r squared plus 1, greatest common factor, 3r to the 4th in front. Okay. So remember, you should really set all of these equal to 0. And that's actually what I'm going to do. 3r to the 4th equal to 0. 2r minus 3 equal to 0. R squared plus 1 equal to 0. Okay. Solving for r here, I divide by 3. R to the 4th equals 0, which means r equals 0. Okay. technically, since that was an r to the fourth, I would have taken the fourth root of 0, which is okay because that's still just 0. And this actually accounts for 4 of your solutions. Okay, so notice this was an r to the 7th to start with, so you should have had 7 solutions. 4 of them are right here. Okay, for this one, you would add 3 to the other side, 2r equals 3, r equals 3 over 2. For this one, okay, I can't factor this, but I can solve it. That gives me r squared equals negative 1. Okay, take the square root of both sides. R equals plus or minus 1i. Okay, because you took the square root of a negative. Plus or minus 1i. Again, you don't actually have to put that 1 there. It's kind of understood. And remember, every time you take a square root and you're solving, you should put the plus or the minus. Okay, now something I would like to note here about your greatest common factor, okay, and finding your solution there, because again, that seems to be something people really struggle with. This, taking out an r to the fourth, is going to give me a solution of 0, because I took an r out of everything. Question number 5, when I took a 6 out of everything, I can't set my 6 equal to 0. That's never going to happen, so I don't have to. That doesn't affect my solution at all. Question number, I think it was 1 on the front, when I took a w out, again, that gave me a solution of 0 because you took a letter out. So if you have a letter as a greatest common factor, then you're probably going to have a solution of 0 somewhere. If you take a number out, then that's not going to affect your solutions at all.